Well, it's 10 after, and I'm really excited for us to be starting our program. Now, before we start, I want to let you know on a couple of things that we are going to do today and what to expect. Today, we hope that each student has either a piece of paper or you may have been sent a worksheet. Make sure you have that in front of you right now. If you don't happen to have that worksheet, that's okay. Piece of paper is great. We're going to be writing down some of our ideas, some of our solutions, and some of our choices. We also need something to write with, so if you happen to have a pencil or a pen, go ahead and get those out now. Also, we're going to be interacting in a lot of different ways. There'll be times where I'm going to ask you to turn and talk to a partner sitting next to you. If you don't happen to have a partner, then go ahead and write down your ideas on your worksheet or on a separate piece of paper. Also, there'll be times where I ask you to write down your ideas, what we call a quick write. We'll also have opportunities where you are going to use the chat box to let us know what you're thinking. We'll also be doing a poll today as well. All right, well, it looks like we're about ready to start, so I want to welcome everybody. My name is Jackie, and I'm coming from the California Academy of Sciences in San Francisco, California. You can see the outside of our museum right here. And our mission is to explore, explain, and sustain the world around us. And one way we do that is actually through our scientists and our problem solvers. You can see several of our coworkers travel around the world to study plants and animals and ecosystems. In fact, we happen to have one of those scientists with us today. And I'd like to introduce you to Elizabeth.
Hi, everybody. Happy Earth Day.
Now, the Academy is actually manages over 43 million species all over our world. And we've been collecting these species since the 1800s, that's right?
That's a long time, and we have a lot of specimens.
So we here working all over the world, we think that the Earth is a very special place. In fact, we think kind of Earth Day is every day. But let's go ahead and explore a little bit why Earth Day was started. Well, it turned out that in the 1970s that people started noticing that there were some changes happening around our planet, and something we could see really closely.
Absolutely. And you know what? One of the things that has changed a lot since 1970 is the amount of stuff that we have. For example, in 1980, experts thought that there would be about, excuse me, there would only be about 900,000 of these cell phones by the year 2000. But in reality, in the year 2000, there were 109 million cell phones. Okay, so 109 million cell phones in 2000. Today, there are 7 billion cell phone connections. That's almost one for every person on the planet. And most of us might think that's a great thing, right? I can call or text or Snapchat with Jackie when I have any questions or just want to chat. They help us connect with one another. They help us transfer information really quickly and many, many more things. But these things, they don't appear out of thin air. They don't grow on trees, right? A lot has to happen to get them into our pockets. So today, we're going to look at our cell phones through the lens of energy.
All right. Well, before we dive into energy, I want us to go ahead and think about what we already know, or what are some of the ideas we already have about electronics and energy. So go ahead and take the next couple of minutes and write down your ideas of how do the things I buy, like electronics or our cell phones, impact the amount of energy I use. Go ahead and take the next couple of minutes and write that down. All right, so go ahead and take these last couple of seconds to write down those last minute ideas or thoughts. Now, when I think of energy, I think of us saying that we need to save energy. We need to conserve it. So I want to take a moment and see what are some of the things that our friends over there are doing to save energy already. So if you could go ahead and teachers call on a couple of students to share out their ideas, go ahead and use that chat box to let us know what are some of the things that you do to save energy. Wow, thank you so much, everybody, for sharing some of these ideas. So I'm noticing a lot of us either turn off the lights when we leave the room, as well as maybe unplugging our electronics. And some of us are using natural light over electrical light. And also, I saw some of our houses or buildings are using solar power, which is really cool. Thank you so much for sharing, everybody. Hearing from you is actually really insightful. And today we're going to build on our ideas as we explore energy. So, you know, we hear a lot about, oh my gosh, we need to save all this energy. We need to turn off the lights. And let's think about what does that actually mean. So what I'd like you to do is go ahead and turn and talk to a partner of what does energy actually mean to you? All right, everybody, let's go ahead and come back together as a group in 3, 2, and 1. Now, sometimes we use words in everyday language that makes sense, and those are all right. But in science, we're going to define energy as the ability to make something change or move?
So, excuse me, I loved seeing how many different solutions you have for saving energy. And one example that we can draw on is for those of you who have solar panels on your homes or your schools. We actually have solar panels on the roof of the California Academy of Sciences. And those solar panels capture energy from the sun, and they change it into energy that we can use to keep our lights on and to power this computer that we're using to talk to you right now. So energy is the ability to make things move or change.
All right, so I know, so we have a definition now of energy. What about how we measure energy? How do we do that?
Yeah, good question. You know, all of you scientists know that we have lots of different units in science. And the unit we use to measure energy is something called a kilowatt hour. The abbreviation is a small k, a large W for watt, and a small h for hour. So that is a measure of how much energy you're using. So what does that mean? Well, let's think about an example of that, because that's kind of an odd unit. So let's imagine that you need to dry your hair. If you had a regular hair dryer and you were drying your hair for about an hour, that would use a kilowatt of energy.
Okay, so now I can have a better idea. So using my hair dryer for an hour would be 1 kilowatt hour.
Exactly, and none of us use a hair dryer necessarily for an hour. It's a lot. A kilowatt hour is a lot of energy.
Yeah, that does seem like a lot of energy. All right, so we've talked about energy and what it means and how we're going to measure it. Let's go ahead and go back to our ideas of the things that we have, those cell phones.
Got it, this thing.
So I would love for you to go ahead and just talk to your partner sitting next to you about what energy goes into your phone or your cell phone. Go ahead and turn and talk. All right, so thank you, everybody. Looks like we have some great ideas that are coming through. We're seeing that a lot of us are saying when we're charging the cell phone is when we're going, when energy is being used by the cell phone. Also batteries, and we're also seeing people think that it's going to use lots and lots of energy. Well, let's go ahead and look at how much energy our cell phone uses by looking at its life cycle.
Well, I mean, I've heard of life cycles for things like butterflies.
Yeah, so it's going to be kind of similar. We're going to kind of work backwards a little bit. We're going to start with the cell phone that we have in our hand.
Oh, cool. Okay.
And so we have our cell phone, and then, but before we have our cell phone, we need to go to a store, but that cell phone needs to get to the store. So we're going to talk about transportation, or transporting that cell phone to your house as well as to your store. That's actually going to take some energy.
Okay.
Then before that, we need to package it. So packaging, creating that packaging as well as packaging itself will create some electrical energy. And then manufacturing it, making the thing. To actually make the object, we need to have energy to power up the machines that are going to use it, as well as the building. So we need to think of that energy. And then even before that, we have to collect the materials. We have to mine or mining those materials. Now, Elizabeth, can you remind us what materials are we mining to get our cell phones?
Yeah, that's a great question. So cell phones have a lot of metals in them. Some of them are rare earth metals. Some are things like gold, like platinum. We use a number of different metals to put into the semiconductors and the batteries in our cell phones as well.
Yeah, so it sounds like we have to get a lot of materials to be able to make it, then to be able to package it, and then to be able to transport it to us to actually have it then in our hands.
You got it. And I think, all of these steps that Jackie just showed us really require energy. And some of it is super obvious. And many of us pointed that out, that when we plug in our charger to the wall, we're using energy. But other energy might not be quite as obvious.
Yeah, we also need to remember after we have our cell phone.
Yeah. Yeah.
So we could also think of energy as when our phone is completely dead, we can't use it, we need to dispose of it as well. All right, well, we've looked at the whole life cycle, and we know that energy is going to come in different places.
Mm-hmm.
Mining it, manufacturing, packaging, disposing of it, and transporting, and even using it. And let's go ahead and think of how much energy might be used in those different things. And the way we're going to do this is we're actually going to rank from highest to lowest which part of the life cycle of a cell phone you think uses the most energy. And so if you happen to have your worksheet, go ahead and write next to each of these icons from highest to lowest, 1 being the highest, 6 being the lowest, you think would use the most energy. All right, so let's go ahead and use our chat box. And can anybody go ahead and share with us what you think uses the most energy? What stage in the life cycle of a cell phone uses the most energy? It looks like one of our friends said mining.
Interesting. Manufacturing or mining.
Some of us are saying using it. All right, so
we're split.
Kind of looks like we're split between manufacturing, making the thing, and using it. And then we have a couple in there that are saying mining, maybe transporting. One of our friends said disposing of it. Great. Well, let's go ahead and reveal what is our number one use of energy. Well, it is. It's manufacturing.
It takes an awful lot of machines in order to take raw materials that are collected during mining to shape them, because let's be honest, I'm not going to go to a mine and find something that looks like this, right? So imagine all the steps that have to happen in a factory to take those raw materials from our amazing earth and turn it into something like this. A lot of energy takes place in the manufacturing world.
Yeah, and let's go ahead and vote. Which one do you think is the lowest use of energy? Based on all of our other stages of the life cycle, what would be the lowest use? All right, wonderful. Thank you so much for sharing those ideas. So it kind of looks like we're kind of split again between packaging and disposing of it. All right. Well, it actually is disposing of it. So let's go ahead and reveal what the other ones are. So from highest to lowest, it would be manufacturing, mining, then using it, packaging, transporting, and then disposing of it. So a lot of our friends were kind of on the right track, picking the top two and the bottom two.
Absolutely.
Wow, thank you so much. So we thought, I actually thought that using our cell phones would use a lot more energy than making the thing.
Well, let's talk about that a little bit more. What is this living energy?
Well, it turns out that this kind of what we're calling living energy is the energy that we is actually used to power and use the cell phone itself. Do you happen to know how much energy we use to power our cell phones?
That is such a great question. Somebody brought that up in the chat box earlier. Thanks for thinking critically about that. And okay, so a hair dryer for an hour, which is really rare to use, but that's about 1 kilowatt hour of energy. Okay, let's see how much a cell phone might use in a year. So we have an iPhone 5 on the screen, and that uses about 3.5 kilowatt hours in an entire year. And depending on how much you pay for electricity, it costs about 41 cents per year to actually charge up and use your iPhone 5. Now, a Galaxy S3, that's a little bit more energy. It's a kind of bigger screen, more processing power, about 5 kilowatt hours, and just over 53 cents per year.
Okay, so let me get my head around this. So remember our hair dryer. So I would have to run my hair dryer for 3.5 hours straight to have 3.5 kilowatt hours, which be how much energy my cell phone uses the whole year.
The whole year, you got it. So using it, our living energy is not actually where most of the energy comes from in the life cycle of our cell phone. Now, it's still important for you, to think about, not having it plugged in all the time and things like that. But interestingly, that's really not where most of the energy comes from in the electronics that we use every day.
Yeah.
Something else called ghost energy is where the energy comes from.
Wait, did you say ghost energy?
I sure did. And no, it's not Halloween, but ghost energy is energy that the consumers, people like us who are using the phones, we actually never see it because it's the energy that's used to make, not run the phone. It comes from mining, it comes from manufacturing, packaging, and the transporting of our cell phones. It's the hidden energy inside of our phones. And as we already talked about, it takes a lot of energy to mine, refine, and create those materials. And we've gotten some questions in the chat box about how much is that. So we just talked about basically 3.5 to 5 kilowatt hours a year to power your cell phone. In terms of making a cell phone, about 280 kilowatt hours.
That's a lot of energy.
Well, when we say a lot, it actually is about 73 times the amount of energy in 1 year to make it than to charge it.
Okay, so I'm hearing a lot of my energy use is going to be going into making the phone itself.
You got it. You got it. So here's what we want to think about on every day being Earth Day, especially this time of year. If you are trying to reduce your personal energy consumption, we started talking about ways we can save energy. One of the best ways we can save energy is to be thoughtful about how often we replace our phones.
All right, well, let's go ahead and explore that idea a little bit further together today.
Great.
Let's all imagine that it's time for us to buy a new cell phone. And I know there's a lot of factors that go into buying a new cell phone, the new color, storage, size, there's many things. We're going to specifically be looking at cost, which I know we think of money. So after all, cell phones are these tiny, powerful computers that are in our pockets. They're amazing, but they're also expensive. So we probably want to think of cost while we're buying a new cell phone. But also, because it's Earth Day and we've been talking about energy, let's go ahead and look at the energy cost that is going to go into buying a new cell phone. So we're going to go ahead and plan on all of us buying a new iPhone 7 together. And we're going to simplify some of our numbers and so to do that, we're going to kind of reduce the amount of energy we're going to use, just so our math is easy. We're going to start all off with 100 kilowatt hours as our energy budget. And then we are going to have a money budget that's going to spend about $550. All right, so we've all got this brand new cell phone. I'm really excited, get to use it. But about 6 months later, our screen breaks.
Oh, man.
And it's a really bad break. So if we touch it, it's actually going to hurt ourselves. So we need to change something. So you all have a decision to make. Do you buy a new cell phone? Or do you repair it? Go ahead. If you happen to have those worksheets, go ahead and flip over your worksheets. At the back, circle your choice. Or if you don't happen to have those worksheets, write down, what do you choose? Are you buying a new cell phone? Or are you repairing it? All right, well, we have our choices. If you bought a new cell phone, you have to add 100 kilowatt hours to your energy budget. Also, you have to add $550 to your money budget. But if you repaired it, all you have to do is add 2 kilowatt hours to your energy budget. That's going to be the amount of energy used to charge the cell phone for 6 months, as well as just add $100 because we have to replace it, and that's going to cost us money. Go ahead and write down your new totals of your energy and your money. All right, so we have either a new cell phone or we've repaired our our cell phone and it's working really well. And about a year later, the new iPhone 10 comes out. Kind of exciting. It's a new phone. You have a choice. Do you buy this new fancy phone, or do you keep your old one that's functioning? You all have a choice. Go ahead and circle your choice or write down your choice. All right, now it's time to add to our budgets. If you bought a new phone, you're going to add another $100, add 100 kilowatt hours, to your energy budget. And then if you happen to buy that, you need to add your money budget. You're going to add in $550. We've done some of the math already for you, so you kind of just follow the colors depending on where you were before. And then for those who kept the old phone, the old functioning phone, you're going to add 4 kilowatt hours to your energy budget because we needed to charge it for the year. And we're going to add no money to our cell phone money budget because we didn't do anything. All right. I'm noticing there's a lot of different ranges of money budgets and of energy budgets.
You got it. I mean, there's a bunch of different things we can think about when we make choices every day, right? And a cell phone's a pretty big decision. They're not cheap. And some of you in the chat box have been asking, is that why they're so expensive? Well, yeah, it takes an awful lot of natural resources to make these tiny computers in our pockets, right?
Mm-hmm.
So one thing to think about, in addition to the money budget, which all of us are probably already thinking about, is something like an energy budget, to think about how much energy goes into making the things that we use every day. Now, let's switch gears a little bit. So we know that making the phone uses money, uses energy and costs money. We know that using it uses energy. But what happens when that cell phone decides not to work anymore, when it's completely unfixable? Where does it go? More importantly, where should it go? Well, this is where we're going to enter zombie energy.
So I'm assuming a lot of our friends have heard of zombies before. Well, we know that zombies aren't a real thing, but the idea behind a zombie is that they come back to life. And if our cell phones are broken, can they actually come back to life?
They actually can. I know, our cell phones can become zombies. Now, they come back to life in the form of other electronics if they're properly recycled. Some of you in the chat box were asking about how can we deal with ghost energy. Remember, that's the hidden energy that comes from the manufacturing, mining, transporting, and packaging of the cell phone. Well, if we don't have to mine the resources because we're able to get them from a broken cell phone, then that helps reduce our ghost energy. So one really great thing to think about is that these little bits of valuable metals like gold, copper, platinum from your phone, they can actually be extracted and reused in circuit boards and solderings. And so by recycling those precious metals and plastics and cell phones, we can save energy and resources that don't need to be taken out of the earth.
That's amazing. And in this day and age when resources, the things that we have are not as available as they used to be, we'll call it resource scarcity, we want to try to make sure that all the stuff that we use lives on after the useful life.
Absolutely. So the next time that you need to dispose of an electronic device, there's a couple things you can do. You can check with the product's manufacturer to see if they have a recycling program. So for example, just today, I got an email that told me about a new robot that Apple's come out with, and that robot can take out the metals from cell phones, and it can take the metals out of 200 cell phones in an hour, which is pretty awesome for a robot. Nice work, robot. And so if you are looking to dispose of an electronic, you can search for take-back programs or recycling programs and the brand of the phone or electronic device that you have. But it's important to remember, too, that cell phones aren't the only electronics that we can recycle. Any electronic device that you have has precious metals in it, and it's important to look for electronic waste sites in your town to properly dispose of them.
Yeah, so we've looked at a lot of different energy uses so far today. We've looked at our ghost energy, the energy used beforehand. We've looked at our zombie energy, the energy used to recycle those things. Let's go ahead and go back to our question of the day and think about, based on all the new knowledge that we have. So I want you to go ahead, if you have room on your worksheet, draw a line under where you had written under our quick write. And let's go ahead and revisit those ideas that we talked about earlier. How do the things I buy, like the electronics and the cell phones, impact the amount of electric energy I use? Go ahead and take the next maybe 2 minutes to write down your ideas. All right, go ahead and take the next couple of seconds to write down some of those ideas. All right. Well, so given what we know now and that it is Earth Day, let's go ahead and we're going to try to create a realistic action plan that allows us to bring Earth Day to every day and reduce the amount of energy we use. So what I'd like you to do is write down some ideas that you have of how can we lower the amount of ghost energy and zombie energy in our stuff we use. All right, it looks like some of our friends are writing in the chat box some of their ideas. Thank you so much for sharing those ideas with us today. So this is part of what we call a Planet Hero Action Plan. And so let's go ahead and look at that a little bit closer.
Great. So many of you are coming up with great ideas and that are totally aligned with what we are thinking about as well here at the California Academy of Sciences. We might want to keep our items longer, and we might want to choose to repair our items before we throw them away. That's going to help us reduce the ghost energy, the energy used to make the stuff that we buy. And remember, we can also think before we throw away. We might want to find out whether the company that made our electronic has a take-back program, and we might want to look for an e-waste disposal site in our town for proper disposal. You know, we didn't give you a specific link to look at because those are often really locally specific. So those are great questions to ask your civic leaders about. If you don't have an e-waste recycling program, ask why not, and ask if you can start one. It's important to remember that all of our actions really can make a difference, especially the actions that we take that impact the ways we use our precious shared natural resources. And we are all so lucky to be living on this amazing planet during this really fabulous time in history. And while our planet is facing some challenges, there are lots of solutions that we can work towards to help people and the planet thrive together.
Yeah, so we actually want to invite you all to join us in a Planet Hero Pledge. And to do this, we are asking you all to come, to use those solutions that we came up with together today. So what I'd like you to do is we're going to create a realistic action pledge, something that you know you can do. And so to do that, I'd like you to choose one action you would like to commit to today to lower your energy impact. Go ahead and write down on your worksheet or on another piece of paper, what is that one action you would like to do? Also, we need to remember how to do this So we need something like, after a phone breaks, I need to remember to repair it. Always take that extra step, or maybe take that a little extra struggle to find somewhere that could actually repair our phones or even TVs, any of our electronics. Then also we need to learn, we need to be able to celebrate this. Celebrate that we are taking action and we are taking steps. So some of those celebrations can be giving each other a high five, or maybe giving yourself a sticker. So what we would like you to do is go ahead and take a moment and write down some of those ideas of how are you going to remember to do this action, and how are you going to celebrate. All right, well, we are thrilled that you all have joined us to be Planet Heroes together today.
Thanks so much, everyone. And if you'd like to explore other simple actions that you can take to use less energy and help people on the planet thrive together, we invite you to check out our newest project at planetvision.com.
And thank you all again for all that you do every day to make this planet such a fabulous place to live. Now, we will be sending some of those resources of take-back programs, as well as how you can create a campaign for yourself to promote either e-waste or creating a drive for all those unused electronics. So thank you all very much. Have a wonderful rest of your day. Thanks, everyone. Thank you, Planet Heroes.